Alright, so let's go up a little bit. Alright, so over here, you should know how to do that basically. So what we did is we're gonna add a ramp to allow us to control the height of this bridge thing. So let's do an attribute fob. And let's add something to the position. So remember, you can split vectors. So vector to float, add it in there, float to vector, put it over there like that, and then do a bind. So we want to bind something. Want to bind curve view. There we go. And do ramp parameter. Plug it in there. Spline ramp. And we want to add something to the position. That. And plug it into position. All right. So now we can control the height of our thing. Maybe we want to multiply the value coming out of this this ramp a little bit. So maybe say multiply constant. Maybe say that this ramp should be multiplied by something like 5 or something. Maybe 10. So then there's some more stuff going on that we can use there. All right, so let's try it in a wrangle. So say that at p.y plus equals a channel ramp. That's going to be called my ramp. It's going to rump over at curve u. All right, plus. Beautiful. All right, let's multiply this entire thing by 10, like we did with the other thing. So, same results, different way of doing it. So again, just use whatever you find more comfortable. So yeah, maybe maybe let's make this more bridge-like. Maybe do it on this one. Yeah, it's more bridge-like, and then yeah, let's start copying some stuff to it. Right, so maybe we first want to be able to say that how many points should this line have. Let's put this to maximum sequence. So turn off segment length and put maximum sequence. So this is going to be how much. So the segments are also going to be how many pieces of wood are going to be in here. So because we're going to copy stuff to these pieces of to these points. So let's say 20 or something. And we kind of need to have a sort of a direction that these things are facing. So let's do polyframe. We did it before, right? Let's do polyframe. Put the normal in the tangent direction. So now we get, if you want to visualize, we get some normals in the tangent direction. Right, so then what we need to do is we need to copy some stuff to it. So let's copy 2 points. Let's copy a box. Right, so what we need to do is we need to be able to tell how big should the box be depending on the length of the line. So I'm going to do it a little bit different than I did it in the original thing. So what I did in the original is, I'm going to go over here, is I am measuring the length of each individual element, and then I am putting it as an attribute. But when that, so what that will do is we'll just make this box be the line of sort of the average of every let me go over there. So let's go over there. So convert line will disconnect each individual element, then it will measure them. So we get attribute, and I'm just gonna grab the attribute here with this expression. With Alt-E, you can open the expression editor like this. I can make it a little bit bigger. So I'm going to get a primitive attribute, and I'm going to like grab the parameter from the zeroed primitive and then shrink it a little bit. So that does work, but it's not going to take into account maybe that some pieces might be a little bit longer. So I thought for this tutorial, I'm going to do it a little bit differently, a little bit more complicated, but you're going to learn more as well. So that might be interesting. So let's highlight our first view again. So let's think about how can we do this. So we need to sort of determine a distance between every point, right? So Houdini happens to have a function called distance. So what the distance function, if I put down an attribute rank, because we're going to do this in a wrangle, within a VOP, we'll do this in a wrangle. If I just type distance and then a bracket, then it will turn blue and it will allow me to open up the help. So if I press F1, then it's going to open up the help. All right, so now you see the distance function here. So what does it require? So it's going to output a float with the distance attribute, and it requires two vectors. So vector A and vector B. So now try to think. What type of what would the vectors need to be that we input into these into this function? So I'm going to give you a couple of seconds to think about it, and then I'm going to explain. All right. So what we need to do is we're going to take a look for each point at the next point, and we're going to take that position. So that's going to be our second vector. So we have a vector, which is the position of our current point. And then we're going to get a second vector, so the position of our next point. And then we can determine the distance between those two. So let's do that. All right. So let's import the attribute from our second point. All right. So we're going to import the vector, and let's call it pos. So again, if you type vector and then pos, so this is going to be a temporary holding vector to use in this wrangle. All right, and it's going to be equal to, we're going to import a point attribute. So if you don't remember how this works, you can again press F1, you get the help file for this. So from which geometry input, which attribute, and then the element number. So we're going to import from the first input. We're going to import the position as a string. So position, and we want to import the point number, but not the current point number. We want to import the current point number plus 1. Put this between brackets, because remember, order of operations, etc., etc. Let's close the brackets. All right. So now we imported the position. So if I'm looking at like this point, I will import the position of this point, because that will be the current point number plus 1. All right. So then what we can do is we can now determine the distance between these two. So let's do that. So let's say that float dist. So again, this is just a holding variable. You could call this whatever you want. Call it cheese if you want. Let's call this dist equals distance. Remember, it's the function that we were going to use. We're going to calculate the distance between the current position of the current point, because remember, vecs and VOPs run over every point simultaneously. So this will apply to every point. So the distance between the position and the pos, so the other position that we imported. And let's write this out to p-scale for now. We're going to not apply it maybe to p-scale, but maybe we will. So let's put it to at p-scale. So type f at p-scale equals distance. Right, let's have a look what this does. And you can see this works, but whoa, what's that? There's a very big last piece over there. So the problem there is that, of course, we're taking the bit number plus point number plus 1, but of course, when it gets to the last point number, well, then this is not going to work. So maybe what we want to do in an extra wrangle, so put a wrangle below it, because we first need to apply this and then need to do the other one, because again, this runs over every point, so it's not going to apply stuff as attributes in between, so we need to do it as a wrangle after that. We're going to say that if the current point number is equal to at numpt, I think it needs to be -1, so let's put this to at numpt -1 or +1, let's see in a bit. Then let's first try it, then let's just set p-scale to 0.1 just to test. And why is this erroring? If at point number equals to equals. All right, so okay, so this worked. So let's have a look. So now let's look in here. So now the last point here will be 0.1. Well, we don't want it to be 0, but we want to import a point position. So we want to do another one. So we want to import this attribute. So again, maybe we want to import, so float, call it p maybe, and then we're going to import a point attribute from the first input. We want to import p-scale, and we want to do it from the previous point number. So that's going to be at numpt -1, I think. Maybe let's see if this will work. Equals p. Okay, that doesn't work. It needs to be -2. All right. So this works. So what it will do is if the point is the last point, then it's going to apply the p-scale value of the previous point. So hopefully that makes sort of sense. If it doesn't, then it doesn't. So now you can see we have this thing going on, and it doesn't matter if it's going to be more or less points, it should still work. So maybe we don't want to do this to the overall p-scale. Maybe we want to do this just to the z-scale. So we could say that maybe we don't want to do the z-scale. Maybe we want to just say f at scale.z, because remember we did scale.z before, so we need to set the other components ourselves. So at scale.x equals 1 and at scale.z equals 1. So I string needs to be a vector. So scale.z equals 1, and then over here the gonna be, we need to import the scale. And okay, so that worked. So you can see now it's doing the z-scale thing. So that worked. Now let's look at our attribute. So that scale is looking good. Maybe let's override our other parameters here so we have some controls for the height. So let's say that we want to be the v at scale.x equals general float, so it's going to be a float, call it x, and then v at scale.y equals What? Oh, and this needs to be X, of course, not C. So this needs to be X. Yeah, there we go. And we could add a multiplier maybe to our at v at scale dot z times equals c. So the default is going to be 1. Then we also have some control to make it a little bit smaller. So now we have some. So now it doesn't matter how many points we have. Let's put the multiplier to 1 so it. Why is this not doing like I expected to? Let's not do this. Okay, so I had to figure out what was wrong, but of course we used scale before. And it was a float, and I still had float put here. So if it was a float and it wasn't working. So what I did is I made it a vector. So vector scale, and then I am saying that at scale.c equals p, which is this one, .c. So now it's working perfectly, no matter how long or small these pieces are. So you can make them higher, you can make them wider. So yeah, that's that part. So what I'm also doing here is I'm generating some. I'm gonna just do some simple UVs on this. So showed that a little bit before as well, but let's just unwrap this thing. Right, so what I had here also was I did which I did with the UV unwrap. So I'm gonna put down here a UV unwrap just to show what it does, but we're gonna unwrap it a little bit differently now probably, so to get some better results. So your UV unwrap by default will just put it in whatever, how many planes you want. But let's just make it better unwrap because it's a box. It's not rocket science. So if you don't know what a UV unwrap is, it's basically a 2D representation of your 3D geometry. So something similar to something like origami, for example. So let's select some primitives. Let's type tab and then UV flatten. It's going to ask us for seam edges. So it's going to be the edges that we're going to cut our geometry with. So let's just select these edges. And then press enter. And then if you type Shift F5, you can see we get a nice unwrap, but it's too big. So we can type UV layout. And then it fits nicely in this UV space. Perfect. Perfect. All right. Now let's do a poly bevel after this thing. And just bevel these edges a little bit. All right. So now we have this stuff going on. Let's have a look. So I'm not sure if the bevel is coming through actually, because we did some divisions. Yeah, I think I'm gonna remove the bevel there and just put it down here. I am not looking at the correct thing. Yeah, let's just put it down there. Let's have a look. Too big. Like that. Maybe some round. All right, yeah, that's looking better. Let's do it like that. So now we should still have UVs. We have gorgeous UVs, best UVs I've ever seen. All right, so let's continue.